In question number 6 of practice exam 2, we are going to find a linear approximation to a given function. So we've got f of xy equals 7 natural log of x plus 2y. And we want to find the equation of the tangent line at the point 3, -1. And then once we find it, we will use it as a linear approximation to find an approximate value of this function at 3.03, -1.03. First, let's do the partial derivatives. So first partial with respect to x. So 7 is a constant multiple, which we're going to keep. Now, we should know that derivative of natural log of u equals 1 over u, and then we multiply by the derivative of the inside, which is u prime. All right, so here we're going to get 1 over, and so again, log of something is 1 over the same something. So that's not going to change. Multiply by the derivative of the something with respect to x, if it's partial with respect to x. So how are we going to do that? We're going to take each term and take the derivative with respect to x, and we're going to add up the results. First, let's start with x. Derivative of x with respect to x is 1 plus. Now, derivative of 2y with respect to x, because it doesn't have an x, no matter how complicated a term, as long as it doesn't have an x, the derivative of it is going to be 0. So this will just become 7 divided by x plus 2y. Now, we'll repeat the same thing for the partial with respect to y. So here we again keep 7 as a constant multiple. Log of something is 1 over the same something multiplied by the derivative of the something, but this time with respect to y. So again, we are doing derivative of x and derivative of 2y with respect to y, and we are adding them up. Now, derivative of x with respect to y will give me 0 because I think of x as a number when differentiating with respect to y. And derivative of 2y is just 2. So that's it. That's the derivative with respect to y. So here, oops, I already messed this up. So 7 times 2 is 14, and then we have x plus 2y. Okay, so next we want to come up with the equation of the tangent plane at 3, -1. So this requires us to plug in 3, -1 into the original function and also in each of the partial derivatives. So first, let's plug it into the original function. So 3, -1. Usually there should be a nice answer, either an integer or a fraction. So in my case, this will be 3 plus 2 times -1. Well, that's just going to be 7 log of 1, but natural log of 1 is 0, so that'll just be 0. Now let's plug in 3, -1 into the x partial and see what happens there. So this will be a 7. Again, none of the answers should ever be left as decimals unless it's the very last point where you're trying to find the approximation. But other than that, everything should always be exact. So fractions, square roots, but no decimals. Okay, so here we got 7 divided by 3 plus 2 times -1. So that's just going to be 7 divided by 1, that's 7. And then the partial with respect to y, so the bottom is just going to be 1 again. And so this is just going to be 14. Okay, now once we find these values, and so there are 3 values, the value of the function, then the x derivative, and then the y derivative. Okay, so there they are. Okay, so now let's come up with the equation of the tangent plane. First, start with the value at 3, -1, but it is 0. However, I'm going to put it just for making sure that if it wasn't 0, you would be putting it here. Okay, then plus partial with respect to x multiplied by x minus the x coordinate of the point, which was 3, plus the partial with respect to y at 3, -1, and then multiply that by y minus the y coordinate, but that's going to be plus 1 because subtracting negative 1 will give us a plus. So normally we are going to simplify this. So this is going to become 7x minus 21 plus 14y and then plus 14. So basically, we're looking for making sure that you know that the distributive law works here. And then we are going to combine the negative 21 and 14, and we can't do anything else with the rest of it. So negative 21 plus 14, I believe that's negative 7. So that goes here. So that would be 7x plus 14y minus 7. The last step is to find an approximation at the value 3.03 and negative 1.03. So very important when you are finding the equation of the tangent line that you don't use any decimals. If any of these numbers, the coefficient of x or the coefficient of y or this number, if they have square roots or fractions, leave them be. Do not simplify them because otherwise you will get wrong answer. In my case, it's very easy because they're integers, but if they were fractions and you rounded them, you will get the final answer incorrect, especially if you round it to only, let's say, 2 decimal places, whereas the final answer, as they say here, needs 4 decimal places. So if you do round, you need to leave a lot of decimals in all intermediate calculations just to make sure that that's not going to affect your answer. So we are going to plug that into the equation of the tangent plane, not into the original equation. Now, I'm actually going to plug in both. I'm kind of afraid that when I do that, you're going to get confused. But why I'm going to plug in both, I'm going to explain in just a second. But right now, all I see is that if I plug it into the tangent plane, which is the linear approximation, so this is approximately going to be negative 0.21. So that looks like I don't even have to round. That's what I get. Now, why would I also plug it into the original function on the test? The reason why I would do that is because I want to make sure that my answer is correct. If when I plug the values 3.03 and negative 1.03 into the original function, if my answer actually is very different from an approximate answer, I know that I will get, I got it wrong. So then I will look at my computations. So here we've got the original function was 7 log x plus 2y. Let's compare because we have a fancy calculator. So as we can see, the answer is very close, and that is good. That just confirms that I got this right. And that's what I would recommend you do on the test.